I'm planning on doing a bit of a different type of video series. This series isn't a tutorial series. I'm a noob when it comes to Godot. I've looked at some web pages and watched a couple of tutorials myself, and I'm looking to explore an area that there's not a lot of tutorials for, so I'm kind of exploring this on my own, but I also don't want to oversell what this video series is going to be. I am not an authoritative source on Godot. I'm about as the bottom of the rung as you can get. I've downloaded, installed, and I know the basics of just setting up a generic scene, but that's about the extent of what I do know. So if somebody is watching this expecting to learn something from a teacher, this is not the series for you. However, if you are a noob yourself and you would like to share experiences with somebody else who's also learning, then this might be a series for you. So I'm looking to explore an area that I'm not seeing a lot of tutorials for. In particular, I'm looking to explore the area of 3D where it comes to code generating, generating or modifying a 3D mesh in code. So I'm not necessarily looking to drag in assets from a different application and create a game. That seems to be where a lot of the tutorials are with Godot. And I'm actually interested in the coding end of it as far as manipulating a mesh. So that's what this video series is going to initially cover. It might expand out to more things, because obviously as I learn more, I'm going to want to explore more, but that's kind of the initial interest that makes me want to start to play around a little bit with Godot. So I guess a little bit of setup here on the environment that I'm looking to develop in. So I did look at GDScript. GDScript seems like a fine language. It is very tightly integrated with Godot. I mean, it is made by the people who make Godot. So I did look at that initially, but I'm not really a Python developer. In fact, I'm not. There's no really about it. I do come from a more statically typed language background. Java's the most recent language I've been using. So I think I'm going to explore this path using the C# version of Godot. So there's not a lot of tutorials out there using this C#. So for Godot, I mean. So I think there's some value in maybe documenting a little bit of the exploration being done there. And also I'm planning on using, I know a lot of people when they are doing C# work in Godot, they're either using Visual Studio or they're using Visual Studio Code. And both are fine IDEs. I'm not trying to say that my preference for not using those is in any way qualitative. It's more of just a personal preference. Since I do come from a Java background, I have been using an IDE for a couple of years from a company called Jetbrains called IntelliJ. And I noticed that they had an IDE for C# in particular. In fact, they have IDEs for many different languages. The downside is the Java one is free. There's a community edition and a professional edition, but the other languages, I don't believe any of them have community editions that are free, so one has to rent them. I do not believe there's a way to purchase them from JetBrains, so it is a rental per month, and one can either rent per language editor, or one can pay a a 1 month fee for access to all of them. So the editor I'll be using for C# is the Rider editor. And again, my preference for that is simply because I'm used to IntelliJ for the Java work, and Rider's interface is very similar to IntelliJ. And I find it to be a very simplistic interface where it's easy to do things without having to jump through a ton of hoops. But that's just a personal preference. I realize there's many debates to be had on pros and cons of different IDEs, so I'm not going to try to say that I have objective reasons why I prefer Rider over something else. It's just something that's kind of clicked with me. It's kind of like picking a game engine too. Whether you're using Unity or Godot or Unreal, you just whatever clicks with you. That's where you want to start exploring. So this is my preference. So C# using Rider with Godot. I'm not sure I've seen any real at-length tutorials covering that. So I think an exploration video series of that environment is at least unique right now. Maybe it'll catch on and more people will do this. Who knows? So as I said, what I'm looking to do is I'm looking to explore generating and modifying 3D meshes programmatically within Godot. And after doing some research, I came across a few interesting pieces of knowledge that I think are necessary before one really gets started. So the first thing I noticed is that the way it seems that this type of workflow would happen in Godot is by using the MeshDataTool. And that kind of took me down a little bit of an interesting rabbit hole, because after looking at the MeshDataTool, this method in particular is what gets the whole process going. Basically, you're going to grab an array mesh from a mesh instance, and you're going to have the MeshDataTool use that to create kind of a helper object that you can use to get faces, vertices, and so forth. But one thing I noticed is in Godot, when you create a mesh instance and you're allowed to give it a simple shape like a cube or a capsule, and it's just kind of pre-built Godot stuff. And from what I can tell, these are primitive meshes. And these are the lists of the primitive meshes. And I believe when you do the pull down on the mesh instance, you're going to get a list that's these same meshes. And what I found out, because at first I tried to use these to do the MeshDataTool, and I found out that it didn't work. I don't think with these primitive meshes you can, like a cube mesh or a capsule mesh, like they themselves know what they can do with themselves. So I don't think like they're meant to be modified just arbitrarily with the MeshDataTool. In fact, if you look at like the CubeMesh here, I mean, I think within that type of mesh, you can do different things like subdividing and such, but it still knows that it's a cube, so you can't just pull vertices all over the place. And I think, and again, please correct me if somebody is watching this and I'm wrong, not only on this but anything else. Please comment and let me know so that I can take that knowledge and learn. But when I was trying to work with this, and I will show you when I start to get into the coding, that I don't think these primitive meshes that you can do anything with. However, I think what you can do, in fact, I got some success, is, well, let's first look at meshes. So when you have a mesh for a mesh instance, it looks like there are two types of meshes you can have. We already talked about primitive meshes, and then you can have an array mesh. And as we saw earlier, the MeshDataTool very much wants an array mesh to start the whole process. So we need to be able to come up with an array mesh. And from what I can tell, I mean, array mesh seems to be like the norm, like when you're exporting out of Blender, like an OBJ file, and you bring that into Godot, it comes in as an array mesh. So it doesn't know, even if it looks like a cube, it doesn't know it's a cube. It just sees it as a mesh, and then you're allowed to arbitrarily modify it. So we'll need to make sure to use an array mesh when we're trying to edit using the MeshDataTool. And the array mesh has lots of things that you can do to it directly, but I think most people are using this MeshDataTool. It just seems like this is where all the magic can happen as far as modifying a mesh on the fly programmatically. So that's what I'm going to do. So I guess the next step here, what I'm going to do, I'm going to bring up Godot. I'm going to start a scene, a project, and I'm going to start a scene. I'm going to set up the environment in Godot. Then I'm going to get Rider going with Godot, and then I'm going to start using some scripting to evaluate what's happening as far as what I can do and what I can't do with these different type of objects. So let's get Godot going. So I'm going to fire up Godot, and the first thing is the screen comes up and asks if I want to open an asset library. No, I want to create a new project. So I'll go create a new project. I'll create something called, let's call it experiment 3D. That probably is good enough. Then create folder, and then create and edit. Okay, so now I want to create a 3D scene and get this whole process going. So I'll create a 3D scene. It'll create a spatial as the root. I'm just going to rename that to main, just so when I save my scene, it's also called main. And then in a 3D world, you need a camera so that you can actually see what you're doing. So we will do that. Let's just initially position this someplace generically useful. We'll get the camera more specific. Not that. We'll get the camera more specific in a little bit. All right. So then let's create a floor so that we have something to look at. So I'm going to go ahead and create a floor. It's not a mesh instance, which is going to be our floor. We will call it floor. And then over here is what I was talking about earlier. When you pull down this list, and you get these list of things. See, I think all of these, that's obviously an ArrayMesh, but the rest of these are these primitive meshes. And I don't believe there's a way to use the MeshDataTool to modify those arbitrarily. But for the floor, we're not going to we're not looking to modify the floor's mesh. So just to quick and dirty create a floor, I think we're fine using this. So we're going to create a new CubeMesh, and let's click on the scale widget stuff, and let's squish it down a little bit. Let's drag it out a little bit so that we have a floor. Okay, now this is something that took me a little bit of research to figure out, because I couldn't figure out why there was this blue tone to my floor when I didn't apply any material to it. And after Googling a little bit, I found out that, well, it's the sky that's up here is contributing to the color of the world. And that's why, because the sky is blue, that's why the cube looks blue. And I don't want that. So I saw some tutorials talking about, well, you need to create a new environment and attach that to the camera and then do this and that. And that's absolutely the way you would have to do that. That's not like that's wrong. But like it just seems like that's a lot of work just for right now to get rid of the blue. Like the rest of the environment I'm happy with. I just don't like the contributing to the blue. So I think what I'm just going to do is just modify the default environment and just get rid of that. I'm not going to create some sort of complicated new environment to set things up, because everything else I'm happy with, just not the contribution. So when you create a Godot project, you will notice that it creates a default environment. So if you double click on that, and then you go over to the inspector, and then open up ambient light, you'll see there's a slider field called sky contribution, and it's currently set to 1, which is 100%. Now when I slide this down, watch the floor here. It's getting darker and darker, and hey, it's black. Okay, so the sky is not contributing anything to the environment, or to, yeah, I guess to the, it's not contributing any color to this environment here. So it's black and we can't see anything now, so we're going to need to have a light. So I'm going to go ahead and save this environment. And now we want to make a light. Well, the quickest kind of light to make, just to get things up and running, is a directional light. So I'm going to go ahead and create one of those. And the thing, let's click back on the move widget. The thing with directional lights is it doesn't care where you are. You could be down here, up here. All it cares about is which way this arrow is pointing. And it doesn't really care if the light is anywhere in space. It just cares about the angle of that arrow to the mesh. So for instance, if I go ahead and rotate this, and I rotate it down, you notice how the floor is getting whiter. It's kind of a gray now. And if it points straight down, it's like really bright white. So, and that doesn't matter where it is, because if I take this and move it underneath the floor, it's still bright white. It's not actually emanating from this actual point. It's just telling the world, hey, there's a directional light that's pointing in this direction. To me, it seems kind of like a cheap and dirty way to get lighting going fast, and I'm good with that. So I don't think I want it pointing exactly straight down. Let's just kind of point it like that. And then, again, it doesn't matter where the lights are at in the scene, these directional lights, I should say. Different types of lights, it does. Like if you use a spotlight or a point light, it does matter, but this doesn't matter. But I like to have them like just floating above so that when I look at the scene, I can visually understand what's going on. If it's below the floor, it doesn't quite click sometimes quickly in my head. Oh yeah, that's what that means. Okay, so the next thing I want to do is I want to make this floor a different color because I don't want everything in my scene to be just as white. So I'm going to go ahead and I'm going to click on the floor and I'm going to go to do a material and I'm going to create a new spatial material and then I'm going to edit it and then I'm going to go to the albedo and I think I'm going to make it like a red. Just, yeah, red stands out. It's ugly, but it stands out. So I go ahead and click the red and then I want to save this material. So I click on save. It's going to ask me how I want to save it, or what I want to save it as, and I'll just say floor spatial material and save it. And you'll notice in the file system here, we now see the spatial material. Okay, so now I want to create the mesh instance that we actually want to start editing. And I'm going to create it with those primitive meshes first to show what didn't work and then how to fix it. So what I'm going to do is I'm going to create a new mesh instance and I'm going to call this cube. And then over here I'm going to pick one of those primitive types and we'll go ahead and pick just a CubeMesh. And then I'm going to drag this up. Since we're not running any sort of physics, I don't care exactly if it's lined up with the floor. I just want to get it so I can see it. And now I want to go ahead and I want to set up the camera so that I'm looking at the scene in a way that I guess is useful. And so I had to look online to see how to do this, but once one knows how to do it, it's actually pretty easy. So if you go up to this view menu, there's these different viewport setups, and you can see currently we're in the one viewport, and it kind of has a little icon or a drawing of what a viewport layout would be, which is one big one here. This one here has two viewports, one on top of each other. Well, I'm going to use the two next to each other just because to me that makes sense for what I'm doing here, but I guess it doesn't really matter. But I'm going to pick this two viewport one here, and you notice it splits it in half like that, but it's still not looking out as the camera would see it. So what you'll notice is over here it says perspective in this view. Now if I click on the camera, you'll notice then it now says preview. And if I click on that, now I get to see what the camera's seeing. And actually that's pretty close to what I want. So if I lift him up a little bit and turn him down a little bit, so that's a good enough layout for me. So now I want to run the scene and make sure everything's working here. So I'm going to hit the little play button. It's going to say this scene hasn't been saved. I want to save it. I sure do. Main dot, that's fine. So then it's going to go ahead and fire this up. and I get to see the preview. So far so good. So now I want to create a C# script so that I can start doing some coding with it. So I'm going to attach the script to the main node, and I'm going to hit the little script add there. Now it defaults to GD script. I don't want GD script. I want C#. So I'm going to click on that. Inherits. Well, I'm not doing anything on this particular node that cares about inheriting from the spatial. I could just leave it as that, but I'm just going to have it inherit from a node so I can move the script around if I want to move it to a different object later. And I'm going to go ahead and create this. So it's going to bring up inside Godot the code in C#, and you're inside a C# editor. I have found the C# editor that comes with Godot. It's certainly functional, but I don't think long term I would be happy using it. Now, there could be enhancements coming down the road here which would make this a much more friendly environment to use. It certainly is functional, but I'm just not used to I don't know how to phrase it. It doesn't seem to quite be comfortable enough to actually work within this type of environment for hours upon hours if you have to refactor code and debug and do these other things. So not a knock on Godot, just saying that an external editor is useful here. So I'm going to go ahead and go back to the 3D view because I'm not going to use the code here. I'll go ahead and save the scene just so we make sure everything is saved and nice and tidy. So now I'm going to fire up Rider so that I can make sure that I can get to that code and that I can make a change to the code to make sure everything's working together. So I'm going to open up Rider, and when I open up Rider it looks like this, and I'm going to pick Open Solution or Project. So when I click on that, it's going to ask me where I want to go, and in this case I want to go to my source directory, and that experiment 3D, and I want to look for the solution file. So this is experiment3d.sln. So I'm going to click on that, and I'm going to hit open, and give it a second to get things going. Now what I've noticed with these JetBrains editors is down here you'll see it's doing stuff, it's reading in files. It's best to just let it finish before you try to do anything. Otherwise the editor is sluggish and you get frustrated very quickly. Alright, so it looks like it's done. So I will open this up, I will open this up. There's my main.cs, so I will click on that. And now I have my editor open. Alright, so let's make a change here just so we can make sure that Godot is reading this. So let's get rid of this. So let's do about the simplest thing one can do. Let's actually print to the screen, print to the console, excuse me, and we'll say I'm in ready, 3 exclamation points. Awesome. Alright, so let's go back to Godot. Let's hit the play button, and in theory, when it runs, we should see down here in the output, I'm in ready with 3 exclamation points. So I hit the play button. It asks, what's the main scene? The main scene is main. Now it's going to build my project. And we'll see down here, it says I'm in ready, so things are working together. Awesome. Okay. So the next thing that I think I want to talk about is working with the debugger in Godot, I think, or in Rider, but connecting it to Godot, I think is undersold sometimes using a debugger. Yes, it can help you debug code, obviously, but if you create a breakpoint and allow the application to hang there, then you can interactively query things to kind of get a better feeling for what sort of methods and data you're dealing with at any particular time as the program's running. And I find that extremely useful. It's a nice supplement to the documentation on the website. So what we need to do here is we need to, well, first let's set up Godot so that it wants to have a debugger attached to it. So you would do that by going up to Project and go to Project Settings. And then you would scroll down here until you get to the mono area, and then you would click on this debugger area. And then it has three fields you have to account for. One's the port it listens on, one's whether it waits for the debugger, and one's the wait timeout. So the port, I'm going to go ahead and put this to 50,000. That's what Rider has by default, and I'm not going to remember that 23,000 number to type into Rider, so I'm just going to make this easy. And then this wait timeout, this is in seconds, so 3,000 is 3 seconds. I guess it's milliseconds. So if I let this run like this, I would have 3 seconds to go to Rider and start the debugging process. And I'm not that fast, so 3 seconds isn't going to work for me. So I'm going to give it 12 seconds because that would account for my slowness, I suppose. And so let's not click on the wait for debugger and hit close. So now if I hit the play button, one's going to notice that there's absolutely no difference in what we notice visually. It's going to bring up the screen and it's going to show the scene. That's not anything different. Well, now if we go back into the same settings and we actually tick this on, so what's going to happen is Godot is going to wait for the debugger to attach. It's going to wait up to 12 seconds. If a debugger does not attach in 12 seconds, it's actually going to shut down. The whole launch process is going to shut down, and it's going to give you an error in the output area that says something like waiting for port not connected or something. So I'll go ahead and click the play button. It'll build the solution. The Godot window comes up here, but then it's just going to sit here, and it'll sit here for 12 seconds. And after the 12 seconds down here, it'll give you a complaining about it can't, some port thing didn't happen. It's basically no debugger attached to me. And there we go. So Godot is now set up to accept debugging, but now we have to go into Rider and configure it for debugging. So that's actually pretty easy. What one does is go up to Add Configuration and click on it, and then hits the little plus button. And then one looks for the mono remote. And this name, which is called unnamed, is arbitrary. It's arbitrary. You can call it whatever you want, but I'm going to call it debug just so it makes sense. And as you see, it defaults to 50,000. That's why I changed in Godot it listening on 50,000 so that this would all work just out of the box. If I didn't change that, I'd have to change this to the 23,000, was it 396 or whatever it was? But I have a decently bad memory, so using the 50,000 that this defaults to just makes sense to me. So I hit OK now. So now this is set up so it can debug if it wants to. So one just has to make sure they have the debug configuration selected, which right now we only have that one. And then when one's ready to debug, one would hit debug, and that would attach to Godot. Well, let's put some code in here so that it actually would be useful for us to debug. So let's go ahead and let's get the node of that cube, and then we can put a breakpoint after there and then attach the debugger and just kind of get an idea for how the workflow works. So what we're going to do is we're going to create a variable called, that's a mesh instance, and we'll call it CubeMesh instance, and it will be the get node. It'll be a mesh instance. It'll be of the cube. And then let's put here end of ready. Okay, so this code will grab the node called cube, which is a mesh instance, and put it in a variable called mesh instance. Well, so what I want to do is I want to have the debugger stop at a certain point and hang there, and you'll see what kind of things we can do that are very useful. So when one wants to, if we didn't add a breakpoint, we just left it like this and attached the debugger, like nothing would really happen because we're not telling the debugger we want to stop at any points. There's no breakpoint set, so we really wouldn't notice anything different than running a normal game, except Godot is going to wait for that 12 seconds for the debugger to attach, but then the debugger is not going to do anything useful except attach. So let's set a breakpoint, and we'll set it down here. So what one does is one hovers over the line that you want to create the breakpoint, and then just left click. And what that means is that the debugger will hang, it'll stop at that line, and it'll allow you to inspect variables and do interactive-y things. So this will be useful for us to kind of inspect some things. So let's go back to Godot, and I'm going to hit the play button. It's going to build the project. The Godot window is going to come up. It's going to hang there for 12 seconds, and I've got 12 seconds to hit the little bug. So I go back to Rider, I hit the little bug thing, and then this will attach Rider to the Godot engine, which it did. And right now, this line is being hanged on. You have a breakpoint there. So what we're noticing is we set up this variable CubeMesh instance, and you notice here down in this variable area, we have a CubeMesh instance equal to this thing. And if we expand this little arrow, we can see a lot of the variables that are in the mesh instance, which by itself is useful. But then there's another level that we can do that will be very useful. This is how I found that those primitive meshes wouldn't work. So while it's at a breakpoint, you can interactively query things. So if one clicks on this little rectangle here, and it'll open up a window, now I can execute code like I would in the editor, but you get the results like immediately. So for instance, I'm going to do CubeMesh instance, and I'm going to go ahead and I'm going to execute the get mesh on it. And I'm just going to hit evaluate. And if I do that, it ran that piece of code like immediately. And so the first thing to notice here is that what was returned from this get mesh is a cube mesh. And that's, remember I talked about that's one of those primitive meshes before. So in theory, this is not the type of thing that we can stick into that MeshDataTool and actually do anything with. It's going to complain that it can't do something with that. But this is what I tried when I was first experimenting with this. This is what I was trying, and it was failing, and I couldn't figure out why, and it took a long time to figure out why. So what I'm going to do is I'm going to close this up and then hit the stop button, which will detach the debugger. And so let's just go, and let's pretend we're going to use the MeshDataTool with this, and it's going to be all fine. It's not going to be, but let's pretend. So what we're going to do is we want to get the mesh out of the mesh instance. So what we would do is we would do CubeMesh instance dot get mesh. Okay, and then if one looks at the MeshDataTool, we want to, I think there was an example down here. So we want to create a new MeshDataTool and then invoke the createFromSurface method with the mesh of the mesh instance. And this 0 is what surface you're going to use. And since this is a 0-based system, 0 is the first surface. Most of these meshes only have one surface, so it's most times going to be a 0. So this is in GD script, but it's not that hard to change that into C#. So what I'm going to do is I'm going to create a MeshDataTool, call it MeshDataTool, and I'm going to create a new one. Okay, and then on the MeshDataTool, I want to create from surface. So the first variable is a mesh, and the second one is a surface, which we said was always going to be 0. Well, not always, but in our case it's going to be 0. Oop, not a mesh. How about the cube mesh? All right, so we notice there's a little underline here, and what the underline is saying is a mesh can't be assigned to an array mesh. It's like, well, okay, we return back a mesh here, and if you look at the node hierarchy for a mesh, you see that PrimitiveMesh and ArrayMesh they derive from mesh. So one of the things you can do in C# is you can cast it to a certain type. So we can try to cast this into an ArrayMesh. And actually, let's shut off this breakpoint. This isn't going to work, by the way, but this is how one would want to do this if it wasn't a primitive mesh. So let's go back to Godot. Let's shut off the debugger because we just want to run this and see what happens. Let's restart things. It's going to build the project. And it blew up. And inside this debugger area, you click on that. Then you click on the Error tab. And it says specified cast is not valid. And the reason one can't do that is, like I said, if you look at the inheritance hierarchy for a primitive mesh, so primitive mesh inherits from mesh, and then mesh obviously inherits from resource. Well, nowhere up the inheritance chain is there an ArrayMesh. So if you look at a CubeMesh, which is what this is, inherits from primitive mesh, which inherits from mesh, and da-da-da-da. Well, none of that's an ArrayMesh. An ArrayMesh, yeah, I guess an ArrayMesh needs to be a non-primitive mesh, as I was saying earlier, because you don't have the ability to cast it because there is no inheritance tree, no way to go up the inheritance path to get to an ArrayMesh. And why do I need that? Again, because the MeshDataTool, in order to use it, requires, when you use the create from surface, it requires an ArrayMesh. I guess earlier I think I was using the commit to surface, which you do use, but this is the one that we need to do to create the ArrayMesh. And the ArrayMesh, or the MeshDataTool from an ArrayMesh, and this won't work for this primitive type. So one can't do that with a primitive mesh. So this is a primitive mesh here, and one can't use the MeshDataTool to manipulate it. So it's like, well, how do I get an ArrayMesh in here? Well, the easiest way to do this, I found, was to go into Blender and just export out its default cube as an OBJ file, and then just move this over to an ArrayMesh. So let's go ahead and fire up Blender. So we already have a cube, it's already selected. So File, Export, OBJ. Okay, let's call this mycube.obj. And let's look here. Apply modifiers, include edges, right normals. And I don't think we need to include the material, so I'm just going to uncheck that, but everything else should be fine. So I'm going to export the OBJ. So we're done there. I can close up Blender. Oh, wait a minute. I think I forgot one thing. Yeah. So I need this to be selection only, or it's going to export the whole thing. I just want that cube that I selected to be exported. So let's re-export it. Okay, we should be okay now. Hopefully I didn't mess that up. Alright, so then on the CubeMesh instance, we want to go over to the inspector and we want to load, and we want to do mycube.obj, and we want to hit open. Now, the scene doesn't look any different. However, if we hit the play button now, one notices it doesn't blow up. And let's actually use our debugger knowledge that we've learned about to actually look at what's in there. Okay, it's going to wait for 12 seconds. Let's put a breakpoint there quickly. Let's hit the bug. So one can see if we look at the CubeMesh now, it actually is an ArrayMesh. Before it was a CubeMesh. And so because this thing is an ArrayMesh, we can do stuff with it. And let's go to that interactive mode again. And if we look at MeshDataTool, and we look at the kind of stuff one can do with it, one notices one can get a bunch of stuff. So let's get the vertex count to see how many vertices are inside that cube. And there are 24. So let's go ahead and just get a vertex. So the 0th vertex, since it's 0 based, would be the first vertex. So if I do that, one returns back a vector 3, and one can see the coordinates here. And this workflow of hanging at a breakpoint and then interactively evaluating stuff, I found this to, like, the workflow is just so much faster than putting in the code and then hitting the play button on Godot and then having it rebuild the solution. And then I know it doesn't seem like much when you're doing it, just a one-time dealie, but if you're trying different things interactively, that is much, much, much faster if you're trying a bunch of things at once to see what works and what's available than trying to do that in the code and then rebuilding the project. Obviously, if you want this to actually do anything, you'd have to put the code in there, but this allows you to kind of tinker with at a certain state in the program and then allow you to interactively try different commands to see what comes back, because sometimes it's not always clear what something does. So I'm going to go ahead and I'm going to, I think, stop the video here. I think we've accomplished quite a bit. I think I've documented what I'm trying to do. I also set up a scene and I connected the Rider IDE with the Godot editor, and I was able to connect them so I can debug. I went through setting up breakpoints. I went through evaluating interactively on a hung breakpoint, and I talked a little bit about what I found out about mesh instances and different meshes and why one can use the MeshDataTool on an ArrayMesh but not on a PrimitiveMesh. And that took me quite a while to figure out, so I wanted to make sure this was documented somewhere, because once you know that knowledge, it moves forward a little bit as far as you're allowed to. It's very frustrating, it was for me anyway, to try to do something with 3 or 4 lines of code and it wasn't working, and I'm like, I don't even want to continue. But then once I figured out why it wasn't working, it made sense why the primitive meshes, I couldn't use the MeshDataTool. So I'm only a little bit farther ahead in my own research than what's documented in this video. I did play a little bit with this commit to surface, which is how one is actually going to modify those vertices. Remember in the Rider editor, we hung on the breakpoint and did a get vertex and we pulled out a vertice. Well, now you can modify that data and you can commit it back to the surface. And if you do that like in your process method, you can get the mesh to real-time move around if you just moving vertices around. And you should be able to add vertices and add faces and edges, and that's what I'm looking to do. I'm looking to interactively like click in the interface and kind of make a poor man's Blender, but don't get overly excited. This is going to be a like one feature Blender. It's going to do like one thing, create an edge or create a face. But I still think there's value there because I don't remember seeing that documented anywhere else. So I think there's value here, especially with C# and Rider. And so I'm looking to take that path as far as I can to see dynamically what I can do to a mesh within the code. In a future series, I'm also looking to see what one can do as far as bringing in NuGet packages. Then again, this is a benefit of using C#, as well as implementing some sort of unit testing so that as a developer, if there's anybody watching this who's a developer, these are the type of things that developers think about, using external libraries to get some sort of feature without having to write it yourself, or unit tests, which can save you a ton of time once your program gets to a certain point, especially when you're refactoring code and you don't want to have to go through every little thing in your game to see if it works. A unit test if properly written, should catch all the important things that you want to catch. I admit I haven't done any unit testing in Godot, and even with C#, I only know minimally how to do unit tests. Java with JUnit, I know quite a bit, but we're not doing Java here. So this is going to be a learning exercise for me, and I think if one is watching this and is a developer wanting to get a bit more information about C#, or at least an account of experience, I think that this would be useful. So I'm going to stop the video here, and if I made any mistakes in this video, please feel free to comment and correct me on where I was mistaken. I think I misspoke a few times. Like I think I said commit to surface was what you had to use to create the surface, and that's obviously not true. You use the create from surface, but I corrected myself there. But if I'm wrong about like the primitive mesh types, maybe there's something I'm missing, or if you have information about, you have experience with doing unit testing or using NuGet in C#, do let me know. I do know one of the downsides of using C# with Godot is that it doesn't work on mobile devices. It only works on desktops. But for my purposes, I'm fine using, because all I'm using is a desktop, and I'm not looking to publish to anything but a desktop. So that limitation of the C# implementation for Godot, I'm not really worried about. So thank you for watching the video, and I hopefully will be back soon with a second part to this series.